Hello friends, welcome back to EMRS Nasik. This is our 8th lecture on the chapter matrices, and in this lecture we are going to see one important example in board examination point of view. Using the elementary transformations, find the inverse of the matrix, and the matrix is of the order 3 by 3. So by using elementary transformations, we have to find the inverse of given matrix. Now we know that we can perform only 6 types of elementary transformations on a given matrix, and out of these 6 transformations, 3 are along rows and 3 are along columns. Now here we are going to use row transformations. You can use column transformations also. So as we have studied in earlier videos how to find the inverse of a matrix, so we will consider this as a matrix A, and we will write this matrix A is equal to I times A. And after writing this, we are going to perform some of the elementary operations on LHS and RHS also. After performing the elementary operations, we come across one relation, I is equal to BA. That means we have to perform those kinds of elementary operations on LHS and RHS so that your LHS becomes identity matrix. Okay, while performing these operations, your A becomes I and your I becomes some another matrix B, and I will keep A as it is. That means this is of the form identity matrix, and some B matrix is there after performing elementary transformations. That I matrix is converted into a B matrix, and that suppose B matrix is like this, and I will write this A as it is. So our given matrix of order 3 by 3 can be written as A is equal to I. So this is A, our given matrix, and we are writing this A matrix as A is equal to I. Now we are going to perform elementary operations. Okay, so I need this element, means A11 as 1, but here we are having only 0. So in order to convert this element as 1, but 1 already it is there in second row. Okay, so what we will do, we will interchange the second row into first row. That means we are going to interchange first row and second row. So what will happen if I interchange first row and second row? Your second row will be now in first row and first row will be second row. Okay, so after interchanging rows R1 and R2, I will interchange rows in left hand side, and similarly I will interchange rows in right hand side. Okay, so now my second step is what? I need this element to be 0, but after interchanging R1 and R2, this element A21 is also 0. That means we have performed already 2 steps, 2 elementary operations, 2 elementary transformations. Now our third objective is we have to convert this A31 element as 1, but we are having here A31 as 3, so this element should be 0. Now how to convert this element as 0? What we will do, since we need this element to be 0, so I will make this element as 3, means this will be 3 and this will be 3. Okay, so for that purpose I have to multiply the first row by 3, means both this will be 3 again 3. If I take R3 goes to R3 minus 3 times R1, means 3 minus 3 times R1, this element will be 0. So which elementary transformation I am going to apply? R3 goes to this R3 minus 3 times R1. So what will happen? The changes are taking place in third row. So what are the changes? So R3 is 3 minus 3 times R1, means 3 times 1. This will give me 0. Similarly here also R3 means 1 minus 3 times R1 is 2. This will give minus 5. And here also R3 is 1 minus 3 times this element. It will give minus 8. So similar kind of operations will take place on RHS also. So this will give me R3 means 0 minus 3 times 0. It will give me 0. R3 0 minus 3 times R1, it will give me minus 3, and similarly R3 minus 3 times R1 gives me 1. So this kind of after applying this kind of operations, these matrices will reduce to this matrix. Now so it is now 1 0 0, yes, we are having 1 0 and 0. Now next step is I have to convert this element as 1. It is already 1 there, means we have already applied, we have already cleared 1 2 3 4 steps. Now our fifth step will be either convert this element 0 first or this element 0. So now what we will do, we will convert this 2 as 0. So for that purpose what we will do, I will make this 1 as 2, means 2 2, both will be 2 2. So if I apply R1 goes to R1 means 2 minus 2 times R1 means 2. So this will give me, this element will be 0. Okay. So R1 means 1 minus, see, you are going to apply this kind of transformations to the elements of first row. So that means 1 minus 2 times 0 will be 1. Similarly 2 minus 2 times 1 will be 0. So 3 minus 2 times 2 will give me minus 1. Similarly on RHS, 0 minus 2 times 1 gives me minus 2. 1 minus 2 times 0 gives me 1, and 0 minus 2 times 0 gives me 0. So this equation will reduce to this matrix. So now next what we will do, see what we are doing, we are converting left hand side matrix as an identity matrix. For that purpose I need this element to be 0. So minus 5 is there. So what I will do, I will convert this 1 as 5. So this will be 5 and this will be minus 5. Okay, so R3 goes to R3 means minus 5 plus 5 times R2 means plus 5. So minus 5 plus 5, this will be 0, but 0 will be in second row or third row? Third row, because we are doing the transformation on third row. Similarly, we are going to perform the same elementary transformations on right hand side. Okay, so after performing left hand side, we are getting 0, 0, 2, and on RHS we are getting 5, minus 3, 1. So this will reduce to this matrix. So now next objective is, if this is to be an identity matrix, this element should be 1. So this element should be 1. That means what I will do, I will multiply 1 by 2 to third row. Means first two row will remain same on RHS as well as LHS. So R3 goes to 1 by 2 R3, because I have to convert this 2 as 1. So first two row will be the same on LHS and RHS, but in left hand side 0 by 2 gives me 0, 0 by 2 gives me 0, 2 by 2 gives me 1, 5 by 2, because we are doing the transformations on third row, that means 5 by 2, minus 3 by 2, and 1 by 2. Okay, now only two steps are remaining. We have to convert these 2 as 0 and minus 1 as 0. So what we will do, R2 goes to, we are converting this element as 0, but for that purpose 2 is here. What we will do, we will convert this as 2, and then R2 minus 2 times R1, R3 sorry, R2 goes to R2 minus 2 times R3. So this will reduces to 0, 1, 0, and similarly on RHS this will give me R2 is 1 minus 2 times 5 by 2, it will give me minus 4, similarly 3 and minus 1. Okay, now only one thing is remaining. Now we have to convert this minus 1 as 0. If I convert this minus 1 as 0, then your LHS will be your identity matrix. So the changes will take place in first row only. Okay, so if I take R1 goes to R1 plus R3, means if I add 1 row and third row, it will give me 0, but the changes are in R1 only. Okay, so R2 and R3 will remain the same. So this will give me 1 plus 0, 1, 0 plus 0, 0, minus 1 plus 1, 0. This is in left hand side, and in RHS minus 2 plus R3 means 5 by 2. This will give me 1 by 2. Similarly 1 plus minus 3 by 2 gives me minus 1 by 2, and 0 plus 1 by 2 gives me 1 by 2. So this is the matrix. Now if you see, my left hand side is now identity matrix, and after converting the same elementary operations on the right hand side, this matrix is some another matrix into A. Now if you see, the multiplication of this matrix and A matrix is identity matrix. That means both are inverses of each other. So I will write this as I is equal to BA, and both are the inverses of each other. That means B is inverse of matrix A, where B is inverse of matrix A and the inverse is given to be this matrix. And we are asked to find the inverse of a given 3 by 3 matrix by using elementary operations, by using elementary transformations. So this is a very important example in a board examination point of view. So you can apply column transformations also to solve this kind of example. Okay, so by using elementary operations we have found the inverse of a given matrix of order 3 by 3. Thank you and have a nice day.